So the section we're covering today is called Systems of Linear Equations, and this is the backbone of this whole course. So the first thing I really want to talk about is what an equation is and how to recognize it. So we're starting from the basics and we're going to build out the definition of a linear equation. All right, so I want you to think about what is the one characteristic that every equation must have. What is the one characteristic that every single equation, no matter the type, must have? It's in the word equals. We must have an equal sign if we're going to call it an equation. All right, so let's look at some examples of equations, and then we're going to determine which ones are linear equations. All right. What about, here's an equation that you're familiar with. A squared plus b squared equals c squared. X equals 1. The natural log of x1 minus x2 equals 7. These are all equations. I'll put a couple more up here. X1, the square root of x1 times x2 equals 9. Five x1 minus 2x2 equals 4. Okay. All right, so all these are different kinds of equations. We got square roots, we got logs, but also we have lines. So we have linear equations in here. All right, so things that are linear will include x equals 1, and this 5x1 minus 2x2 equals 4. So these are linear. All right, so let's write out what a linear equation looks like so that we can characterize it all the time. All right, so I will often use EQ to the n to represent equation. So linear equation will look like this. A1 x1 plus a2 x2 plus, and we're going to continue in this fashion, 2an x of n equals b. All right, and what do all these letters mean? Well, the AI's are just coefficients. Both the AI's and the B, these are going to be real or complex numbers. And this letter N, the number that we get to, our last index, is a positive integer. So anything that looks like this is going to be a linear equation. All right, and so in this section, we're going to talk about a system of linear equations. So let's go ahead and get that definition. All right, so this is what my shorthand for definition. So first definition, a system of linear equations, also known as a linear system, consists of one or more linear equations. Involving the same variables. Okay. All right, so let's look at some examples. I'm going to move to a different page here. All right, so here are some examples of linear systems. So let's say we have the equation x1 minus 2x2 equals -1. And we also have negative x1 plus 3x2 equals 3. All right, so this is a linear system. We have two linear equations and they are involving the same variables. And we can solve these systems pretty quickly. You can probably look at these. So let's look at the first one. x1, x2 is going to be the solution. So can anyone give me, I'm pretending like this is a real class, think to yourself, can you figure out an x1, x2 combination that will solve this system? Perhaps 1, 1, 3, 2 would work. So we should be able to plug in 3 for x1, 2 for x2, and that would solve this first equation. All right, let's look at the second equation. Solution will be x1, x2. So we want to think of any x1, x2 combinations that will make this statement true. 0, 1 is probably the first one that may have come to your mind. And also 3, 2. So notice 3, 2 is a solution for both of these equations. So it's going to be a solution for the complete system. All right, so we can look at this on a graph. So that's what I'm going to do. I'm going to draw out a little graph here. Okay. All right, so this is going to be my x1 axis, and this is my x2 axis. This could also be written as x and y's. Get some tick marks on here. Okay, so I am going to look at the first equation up here. I was using green, so I'll continue to use green. A solution for the first equation was 1, 1. So I'm going to plot that here. And another solution for that first equation is 3, 2. Okay, and so if I connect these, create a line, we'll pretend like it's perfect. It is not. All right, so these are going to be all of the solutions of equation 1. So everything on this line can be used to plug in equation 1 and make the statement true. Okay, and then let's go ahead and look at equation 2, the solutions are 0, 1, 3, 2. Okay, connecting these, pretending like these are perfect lines, these are the solutions of equation 2. Everything on that line is a solution of equation 2. And we see they have something in common, like we knew. 3, 2. This is going to be the unique solution of the linear system. All right, so in the next video, we'll talk about what solutions are.